Hi there and welcome. Thanks for joining this on-demand session. 5 real-world applications of next-level physical access control systems. I'm Jeremy Fromm, and today we're exploring how access control is evolving, thanks to intelligent controllers powered by the Mercury embedded application environment. This is about more than just speed or redundancy. It's about solving real-world problems at the edge, where security decisions actually happen. Let's get started. Let's start with what we're moving away from. Legacy access systems have relied heavily on centralized servers. That worked for a while, but it came with real limitations. First, server dependency. Complex decisions always had to go to the server. Next is the fragile networks. A dropped connection could interrupt all your access. And then there's those single points of failure. One system going down could affect dozens of doors. And finally, integration overhead. Every added subsystem meant more cost and more complexity. In today's world, that's not just inconvenient, it's risky. Now the model is shifting. With the Mercury embedded application environment, we're bringing real decision-making and power to the edge. Here are 3 key advantages. Number 1, local autonomy. Decisions are made right on the controller. Number 2, reduced latency. No more round-trip delays to the server. And number 3, distributed resilience. If the server or network goes down, your system keeps running. And with Mercury's new environment, the controller becomes a secure platform, capable of running logic, enforcing workflows, and even hosting small applications directly at the edge and on the controller itself. Let's look at 5 examples of how this comes to life in the real world. We'll talk about each of these in more detail on the next handful of slides. The first scenario is how local emergency response is handled. In an emergency, every second counts. So let's say a panic button is pressed in a school or a healthcare facility. With a traditional system, that signal may need to go to a server, be processed, and then sent back down to lock the doors or trigger alarms throughout your whole system. But with intelligent controllers, all of that could happen locally on the controller. A panic button connected to one controller can instantly trigger lockdowns, alarms, and even lighting changes across your facility without needing a stable network connection or a server. It's fast, reliable, and in a crisis, it can be life-saving. The next scenario is local door interlock enforcement. In certain environments, door sequencing isn't optional. It's mission critical. Take a clean room, for example. These tightly controlled spaces where even a brief contamination event can halt production, damage materials, or result in costly rework, especially in industries like pharmaceuticals, semiconductors, or biotech. To protect that environment, you need an airlock with interlock doors, meaning door A can't open unless door B is fully closed and sealed. If that sequence fails, or even lags for a second too long due to server latency or network delay, it could lead to pressure loss, airflow disruption, and potentially contamination that shuts down the whole line. With the Mercury embedded application environment, that sequencing or logic could reside directly on the controller at the edge. No server, no round-trip delay, no external logic layer required. And it's not just about enforcing open-close rules. You can add nuance. It could enforce occupancy limits, it could add timing delays to ensure proper air exchange, or it could validate that sensor thresholds like pressure or humidity are met before unlocking the next door. That makes the system smarter, faster, and more resilient, even if the network or server goes offline. It also makes these environments safer and more compliant by reducing the chance of human error or delayed system response. On to integrated elevator access. Elevators are often overlooked in access control, but they're central to user experience in high-rise buildings and large facilities. Historically, managing elevator access meant using separate systems or relying on slower server lookups to determine floor permissions. But with Edge Intelligence, you can evaluate access credentials and permissions locally, right at the controller. Even better, many modern buildings are using destination dispatch elevators. Here's how that works. A user badges in, often in the lobby, they select a floor on a kiosk, and the system tells them which elevator to take. Once they're in the cab, there's no buttons to press. There are many benefits to this approach. The first is that the system groups people heading to similar floors together, making elevator traffic faster and more efficient. Another is that you avoid the stop at every floor scenario when you're late for a meeting. And finally, users don't have to fumble with or have to get to the buttons of the cab. They just badge in at the lobby, ride ride and go. When this gets integrated with Mercury, access permissions and dispatch logic can all be validated at the edge, enabling a smarter, faster, and frictionless experience for the user. Local dual-factor entry is another area where edge-based processing could be important. Dual-factor authentication has evolved beyond just the card plus PIN. Today, we're seeing one-time passwords or OTPs generated by mobile apps. We're getting push notifications for real-time approvals. And then there's federated credentials that unify physical and logical access through PKI or public key infrastructure. Traditionally, these factors required validation by a cloud-based identity provider or a server-based logic engine. But with Mercury's embedded application environment, that validation could happen locally at the door. For example, the controller can validate an OTP directly while waiting for a physical badge to scan. Another example, a push to verify signal could be initiated and processed at the edge in conjunction with a traditional badge. And access can be granted based on a token that's shared across both physical and digital domains. This means high security dual-factor access still works, even if the server's offline or the network's unstable. It's a huge step towards zero trust architecture and unified physical and logical security strategies. And last but not least, centralized hardware management. So far, we've talked about decision-making at the edge, but what about managing all of this infrastructure? With modern tools and protocols like OSDP, you can onboard devices, manage firmware, rotate encryption keys, and apply configuration updates remotely from a centralized location. The intelligence still lives at the door, but the management lives in the cloud or the data center. This does a few important things. It reduces truck rolls and site visits by integrators. It standardizes deployments across multiple facilities and locations. It enables remote diagnostics and faster updates. And it dramatically reduces the risk of configuration errors. But perhaps most importantly, it could substantially strengthen your cybersecurity posture. Pushing firmware updates, rotating passwords, and maintaining encryption keys securely is consistently one of the biggest gaps in legacy physical access control systems. This model helps close that gap at scale. And when you look at the full picture of reduced operational overhead, improved uptime, and stronger cyber hygiene, this capability alone may offer the biggest impact for all users, whether you're managing 10 doors or 10,000. It's not just smarter access control, it's smarter system ownership. The MP series of controllers from Mercury are designed for what's next. There's more computing power, there's better cyber protections, and there's greater adaptability for future applications. It's not just an upgrade, it's a foundation for long-term innovation. Thanks again for spending time with us. If you're looking to modernize your physical access control system or solve complex challenges with smarter and more resilient solutions, start looking at the edge. Visit mercury-security.com to learn more or connect directly to talk further. We hope to hear from you.